Okay, so this is a simplified theory of learning based on a model that I've seen by a guy called Greg Ashman. Okay, let's have a look. So basically, what the idea is that any new academic concepts, so stuff that we're needing to learn, like in school, that comes through into what we call the working memory. All right. Now, the working memory has got a limited capacity. It acts a bit like a bottleneck. Can you see this is like a shape of a bottle? Okay. So all of this concept, ideas, knowledge, understanding has got to pass through this bottleneck. In other words, it's constrained. Okay. I think it acts a little bit like RAM in a computer. Okay. The RAM in a computer can only manage a certain number of tasks at any one time. If you overload it, you get these things happening, don't you? Okay, on on your computer. Yeah. All right. So the information is heading into hopefully the long-term memory. Okay, and the long-term memory is effectively limitless. All right, so the idea is that we need to get the new academic concepts through the bottleneck, through this constrained part of the brain working, into the long-term memory. And what we know is that when there's a change in the long-term memory, we can say learning has taken place. All right. So the long-term memory is, in our computer analogy, is a little bit like the hard drive. You can just store and store and store and store. Okay. And then the brain is almost limitless. Obviously, on a hard drive, you've got the capacity of the drive, but you get the idea. All right. So knowledge, concepts have to pass through this bottleneck first in the working memory before it can enter the long-term memory. All right. Now, what that means is that if we overload the working memory, for example, in a lesson, we're giving too many new concepts at the same time. In other words, we haven't broken down complex ideas into simplified ideas, into chunks, and we deliver them in a methodical way, we can overload the student's working memory. It's like this begins to happen in their brain. All right. And they are going to have problems processing this. And that's going to impact on it heading over here. Okay. So you're much better to break things down into chunks. So it's not too much at the same time. So that will affect how you sequence what you teach in the lesson. Because now that you know this, you can see in your students' brains this bottleneck, and the idea that as a teacher you want to think, right, I'm aware of this bottleneck for working memory. So I do not want to overcook the working memory. I don't want to overload the RAM, because that's going to interfere with knowledge getting over here into long-term memory. Okay, and I guess also that's why when this is happening, if we're getting lots of distractions, that's going to affect this as well. Okay, so if we can think about this as a model for how learning happens, it's going to be a good thing. That's going to help us think through in a much more clear way how we plan the step-by-step process that happens in the lesson. So we're only introducing some new concepts in a kind of drip feed, so we don't overdo it. Then it's got a much better chance of heading over into long-term memory. And when we get change there, learning has happened. That's what we want. Yes? So I hope you found that useful.